Hello everyone and welcome to part 3 of a multiple video series where we are covering the operation of electric circuits with a focus towards electrical quantities. And in today's video we are going to be introducing the one and only current and magnetic force. So buckle in and let's get started. For starters, let's ask the question, what is current? So current is the rate of movement of net positive charge per unit of time through a cross-section of a conductor. In a previous video we covered conductors, so if you haven't watched that, I recommend going to that. It's a quick short video and a crash course introducing conductors and insulators. But getting back into current, so current uses the variable I, and current is measured in the units of amperes, which is abbreviated A when specifying certain values, which represents 1 coulomb per second. The net charge transferred at a particular time is the net area under the current time curve. Also in a previous video, we introduced Coulomb's law, which involves the electric force associated with charged bodies, whether that's 2-point charges or maybe even multiple. Now we are going to introduce Ampere's law of force, which is concerned with magnetic forces associated with 2 loops of wire that are carrying currents by the virtue of the motion of charges in the loop. However, keep in mind the schematic shown here is isolated current elements, where that cannot exist without a source or sink of charges within the loop. There are 2 formulas that we are representing here, and the differential magnetic forces experienced by the differential current element due to the currents 1 and 2 respectively. And we're going to dive into what these values mean and what the formula kind of interprets. So dl is the differential element for either loop 1 or 2. The A variable is the unit vectors along the line joining the 2 current elements. R is the distance between the centers of the elements. Mu is the permeability of free space with units newtons per amp squared, or more commonly known as henries per meter. Now, when showing this formula and each of the variables, it's helpful seeing the schematic on the left on how they are utilized within the loop 1 and loop 2 illustration. Each current element is acted upon by a magnetic field due to the other current element. The B bar value, or variable, is known as the magnetic flux density vector, with units being either newtons per ampere meter, or Webers per square meter, or even Tesla. Current distribution is the source of magnetic field, just as a charge distribution is the source of an electric field. The Biot-Savart law equation can be expressed in terms of moving charge, since current is due to the flow of charge. I hope you enjoyed this crash course into current and the electric force. So if you found this useful, please make sure to like and subscribe. In the next video, we are going to be covering electric potential and voltage. So make sure to go check that out when I upload it. And I hope to see you guys in a future video.